we are going to study all the important topics of Unit 8, the D and F block elements of Class 12 NCERT Chemistry. I would like to stress the point here that I have prepared the content very simple and easy that you all, including the students from the state boards, also will find this really easy and useful. Please do like, share and subscribe to my channel. Now, first of all, you can see the periodic table. You all would be very familiar with it. And here you can see all the elements arranged in rows and columns. So, what are D block elements? D block of periodic table has the elements of groups 3 to 12. You can see the elements of group 3 to 12 in the middle of the periodic table, and in which D orbitals are filled in each of the 4 long periods. So, you might have learnt about the orbits and orbitals or subshell. So, those who are not very familiar with it, I will have a special session on those in another video. So, here what are F block? F blocks are elements in which 4f and 5f orbitals are placed in a separate panel. You can see at the bottom of the periodic table. So, you can see that they are called lanthanoids and actinides, and here we give the names transition metals and inner transition metals. They are often used to refer to this. Now, you can see here in the diagram given that transitional elements are elements which contain an incomplete D subshell, that is from D1 to D9 in at least one of the oxidation states of their compounds. So, you can see that the element Sc, that is, it is having vacant D orbitals and no element in S orbital. It is 3D0. So, no elements, it's an incomplete D subshell. And also for Z and zinc, you can see that it is the oxidation state is 3D10. So, here you can see that the elements has incomplete D subshell. So, and you can see that the elements of the D block, they start from period 4. So, you can see all the elements given in the table here for your convenience. And period 5 yttrium, starting from that till cadmium, silver, everything belongs to this group. And period 6, you can refer to the names of all these symbols in your NCERT textbook. And period 7. So, 4, 5, 6 and 7, you can see at the bottom of the screen the arrangement of the it is marked in the figure at the bottom. So, next, what is the position of P block in periodic table? So, it is clearly shown in this figure that we have got actually 4 blocks like S block, D, P, F. So, S block belongs to the left hand end of the periodic table. D block comes in the middle of the periodic table, P on the right end, and F block are placed as a separate panel below the periodic table. Now, you can see that used a colored chart where pink color shows metal and light green color shows that it is a semi-metal. It is neither a metal nor a non-metal, and yellow colors are non-metals. And next we will give a definition for D block elements. So, what exactly are D block elements? As I already said, elements belonging to group 3 to 12 are known as D block. Why they are called so? Because the elements belonging to these group, the last electron will go to D subshell or D orbital. And actually, as we saw in the figure, D block elements are seen in between S and P blocks in the long form of the periodic table. Now, I said that they are also known as transition elements. Why they are called transition elements? What is a transition element? It is the one in which the D orbital in its ground state is incompletely filled, or it is incompletely filled in any one of its oxidation state. That is, a transition element usually has a partially filled n-1 into D orbital. So, n is the number of orbits and n minus 1 into d orbital. So next, how d block elements and transition elements are different. What is the difference between d block elements and transition elements? So you can see that all d block elements, they are not transition elements, but all transition elements are d block elements. So why all d block elements are not transition elements? Because d block elements like zinc, they have full D10 configuration. Earlier we saw that in zinc we are having the full D10 configuration in ground state as well as in common oxidation state. So accordingly it does not fit the definition for transition element. Still zinc is also a transition element. Now we will go through a few questions based on this. Like the first one is, which of the d block element may not be regarded as transition elements? So it will be zinc, cadmium and mercury, Zn, Cd and Hg. Now second question is, why zinc, cadmium and mercury are not considered as transition elements? Why they are not called transition elements? Because they do not have vacant d orbitals. What is the condition? That they should have incompletely filled d orbital, but in these cases they don't have vacant d orbitals, neither in atomic state or any stable oxidation state. Now why scandium is a transition element but zinc is not a transition element? As we said earlier, scandium is Sc, that is transition, because what is the symbol of scandium? It is Sc, because it has incompletely filled d orbitals in ground state, but zinc has full D10 configuration in their ground state as well as in their common oxidation state. Now fourth one is, copper atom has completely filled d orbital 3d10 in its ground state, yet it is transition element. So this is an exception. Why it is like that? Even though having completely filled d orbital, why copper is a transition element? Because copper, its atomic number is 29. It exhibits normally +2 oxidation state, whereas it will have incompletely filled d orbitals, that is 3d orbitals. So it is a transition element. So the next one is, silver atom has completely filled d orbital, that is 4d10 in its ground state. That is, in ground state silver is having completely filled d orbital, but still it is a transition element. Why? So the explanation for that is, silver atomic number is 47. Even that, like copper, shows +2 oxidation state, wherein it will have incompletely filled d orbitals 4d. So it is a transition element. Now the last one is, why the name transition given to the elements of d block? Why it is given? Because only because of their position between s and p block elements. So hope you understood all the questions. You just keep on going through it repeatedly. And now we will have a look at the general and physical properties of d block elements. So we have got a few properties listed out here which are very important. First is physical property, second is atomic and ionic size, third is ionization enthalpy, fourth is oxidation state of d block elements, then the fifth one is colored ions, sixth is catalytic property, magnetic property, then formation of complex compounds and formation of interstitial compounds. So here since this is a big very vast topic, I have divided this into 5 parts. So we are watching the part 1 of this video today. I will be uploading the remaining 4 parts one by one, because by the time you are thorough with this part 1, then after that it's better always to learn part by part, because if you try to learn everything fully, then you will be totally confused. So better you read each part, then go through the questions I give, and then you move on to the part 2. Now first, what is boiling and melting point? They are called enthalpies of atomization. So for the transition elements, you can see the chart, in the chart the trends in melting points of transition elements. So along the x-axis we have got the atomic number, and then I have given 3 different colors for 3 different elements. So for Mn, manganese, I have shown it in red color. You can see the other elements also: titanium, vanadium, chromium, iron, cobalt, nickel, palladium, etc. And for the middle one, then you can see the elements there, and for the green one, so you can see it has 3 different graphs. So a large number of unpaired electrons take part here in the bonding. So the metallic bonds are very strong. So that is the reason why they have high melting and boiling point. Now they are also having high enthalpies of atomization, and you can see that the maximum will be at the middle of each series. So due to the large number of unpaired electrons taking part in bonding, that is why they have very strong metallic bonds, so they have high enthalpy of atomization. Now next you can see a very well laid table in which the outer electronic configuration of the transition elements, which is in the ground state, is given. I have divided it into 3 series, first, second and third series. So in the first series you can see for each element Z denotes the atomic number. Then in the different elements starting from scandium, it's shown with the atomic numbers 21, 22, 23, etc. Then for the first one, scandium, atomic number is 21, 4s orbital has 2 electrons and 3d has 1 electron. Like that you can go through the entire table and try to understand how many number of electrons go into each. So in the second series you can see that 5s and 4d subshells are given. You know, there is a particular order in filling up of the subshells. So if you are not thorough with that, even that topic I will be dealing with it after we successfully complete all the units. Then you can see in the third series is that 6s and 5d are given. So you go through these element arrangement of electrons in different subshells, and now you can see in this table, like again I have shown the name of the element, atomic number in a more easier way. So how electrons are getting filled up in the 3d subshell as 3d subshell. So you know, orbital and subshell are one and the same. Orbit and shell, it is same. So all these concepts you would have learned before as well. And we have got 4s subshell here. And one particular thing you can see in this figure is that for element chromium, like with atomic number 24, we are having only one electron which is unpaired in the 4s orbital. And also for copper with atomic number 29, only one electron which is not paired, except that all the other elements here, they have a pair of 2 electrons in the 4s orbital. And you can see that scandium, we have got only one electron in the 3d. Like you can see 1, 2, 3 for the next 222 atomic number, 2 electrons. Then like after that 3. Then you can see with atomic number 24, as I said earlier, 3d subshell, each of it has got 1 electron, and 4s also has only 1 electron. Then after that manganese 25, there 3d has got 1 electron each, and 4s has got 2 electrons. And then iron Fe 26 atomic number. Here in 3d the first block has got a pair of 2 electrons, and all the other only one each, and 4s has got 2 electrons. Then cobalt, you can see after the first row, the second after the first square, second square also has 2 electrons, then 1 each. 4s has got 2 electrons. We can see that if you closely look into the figure, there is a definite pattern of filling up of electron, whereas in zinc atomic number 30 in 3d all has got 2 electrons, whereas in 4s also there are 2 electrons. And why in chromium and copper they have got only 1 electron, I will explain that. But before that, we will just have a look at the atomic and ionic size of the 4th period transition elements. You can see along the y-axis we have got atomic radius, and we have got different elements arranged in it. And then you can see that here another chart where the colored lines show the different elements, like green for scandium, blue for yttrium, and red for La, that particular group. And how do they vary along the y-axis? We have got the radius. So that is the trend in atomic radii. You have to just look at the variation of how these elements are, and on the graph is shown in the figure. And you can see that along the rows, that is from left to right, the nuclear charges increases, but the penultimate means the last but one, the one before the last one, d subshell it is having poor shielding effect. So atomic and ionic size will always remain the same, since the shielding effect, what is meant by shielding effect? From the outermost attraction, whatever it is, there is no shielding at all. So the size cannot, the atomic and ionic size, it doesn't increase. but the nuclear charge will increase. So also the radii of the third series, they are the same as those of the second series. There isn't much difference between the radii of the third and corresponding second series. Mostly they are the same only. And why this phenomena is happening? Because what happens is that the 4f orbital will intervene during the filling up of 4f before 5d orbital. So actually before 5d is filled up, 4f is coming into that filling part, and that is why there is a regular decrease in atomic radii, which is known as Lanthanoid contraction, which is very important concept for the examination point of view also. That is why it compensates for the increase in atomic size with the increase in atomic number. And also because of the Lanthanoid contraction, what is the final result of it? Only thing is that the second and the third D series shows the same radii. See, you can see ZR zircon and hafnium. HF both has only slightly a small difference only, 160 and 159. So because of they'll ask you why this is happening, why they show the similar radii, and they'll be asking in the choice or whatever it is, the answer should be. Mostly these type of questions come for the NEET exams as well. This is due to Lanthanoid contraction. And what is, as we already discussed, so Lanthanoid contraction, we saw that before filling FD orbital, filling of F4F orbital takes place. So as a result of that, the decrease in atomic radii causes Lanthanoid contraction. Now, ionization enthalpy, you can see that first ionization energy is of fourth period transition elements. This is a comparison. You can see the increase and decrease of the ionization enthalpies of different elements clearly shown in the chart. So from the figure itself, we can know that zinc has more first ionization energy than copper. It's clearly shown in the figure. Then next one is again you can see that second ionization enthalpy, third ionization enthalpy. For second ionization, you can see that chromium is in between vanadium and manganese, Mn. So you can see in the figure, where is Mn? Almost in the middle. V is then after to the left side of Mn, you can see Cr chromium, then V. So Cr is in between V and Mn. So Cr E2 ionization enthalpy, second ionization energy is greater than V but less than manganese. So like that, nickel, copper and zinc. So copper is greater than nickel but less than copper lies between nickel and zinc. So IE3 also, Fe is less than iron. You can see in the figure, where is iron? It is less than manganese. Iron is greater than manganese in the figure. And copper is less than zinc, and copper is greater than nickel. So you can see from the figure and find out which is having greater ionization enthalpies from the figure. And what happens is that as the nuclear charge increases, accompanying the increase in nuclear charge, automatically the filling of the inner d orbitals happens. So because of that, the ionization enthalpy along each series of the elements from left to right will increase. But all these can have small variations or exceptions. So what are the oxidation states of transition elements? They always show variable oxidation state. Why? What is the reason? Because due to the small energy difference between n-1 that is penultimate d subshell and ns subshell electrons from both the subshell taking part in the bonding. You can see the different oxidation state. For Sc it is only +3, titanium shows +2, +3, +4, like that. V +2 to +5, Cr +2 to +6, Mn +2 to +7, Fe +2 to +6. There is no +5 for iron. Co is +2, +3, +4, nickel is +2 to +4, copper is +1 and +2, and zinc is +2. So you can see one important point here, that the elements which show the greatest oxidation state, always they are seen in or near the middle of the series. Like example, manganese, it shows all oxidation states from +2 to +7. And normally lower oxidation states, they are found when a complex compound or ligands which are capable of pi acceptor character. In addition to both sigma bonding and pi acceptance is also possible. In such cases, low oxidation states are found. And the elements which give the greatest, as we already saw, it occur in near or middle of the series, and low oxidation states are found in cases, compounds where both pi acceptance and sigma bonding can be seen, like in example NiCO 4 times and FeCO 5 times, the oxidation state of nickel and iron will be 0. And they also, the transition elements also have a tendency to form colored ions. Most of the transition compounds like ionic as well as covalent, they are colored both in solid state and in aqueous state, and the elements or ions, they have unpaired electrons. Because of that, it produces colored compounds. You can see the different colors here. Titanium oxide, sodium chromate is yellow, potassium ferrocyanide reddish, nickel nitrate hexahydrate green in color, zinc sulfate heptahydrate is white in color. Then in the bottom row you can see scandium oxide, then vanadil sulfate dihydrate blue color, manganese chloride tetrahydrate, and then cobalt chloride, copper sulfate pentahydrate. For your easiness in referring, I have given the corresponding colors to all the salts. Then the name transition metals and intertransition metals, they are often used, as I already said, to refer to the elements of the D blocks and F blocks. So zinc, cadmium and silver, they are not usually considered as transition elements due to the absence of unpaired elements in D orbital. As again and again repeat this point because it is highly important. Now we already discussed the oxidation states of the first row of transition metals. Then once again I repeat that the transition elements show variable oxidation state because of the small energy difference between n-1d and ns orbital. So both that means both n-1d and ns, both electrons take part in the bonds formation. That is why they show variable oxidation state. And why these metals have a high melting points? Because the involvement of electrons from n-1 into d in the bond formation in addition to the ns electron, and in any row the melting point will rise to the maximum at d5, but for some metal elements like Mn and Tc, like they show some anomalous values, and also they fall regularly as the atomic number increases. I want to again repeat the point that we are not studying the lesson from NCERT textbook in depth or in detail, because our main purpose is to go through all the important topics and try to have a better understanding of all the concepts, so that you cannot take a long time to study a particular subject, because you have got to divide your time between all the subjects. So when you are doing final revisions, you have to focus and finish off the topics units quickly. So that is why I am mainly giving highlight or importance to going over all the important topics quickly without giving detailed explanation to each and every concept. And that is all. With that we come to the end of this session, and as always I say, you must prepare inorganic chemistry from NCERT book only, as it is fact based, and it does not contain many concepts. So it's better always to prepare inorganic chemistry mainly from the textbook and from the notes. I am sharing it here for all of you. And for physical chemistry, you must study theoretical concepts and numerical problems from the NCERT textbook, and we will be solving numerical problems as well when we do our session for physical chemistry over here. And organic chemistry, it's very important. You have to be thorough with the concepts, and you have to be clear before you solve the question. And always you review and solve NEET papers of previous years. I'll be trying to solve the previous year's question papers after we finish off all the units. This will give you a fair idea of the question pattern. And always you must prepare these topics and simultaneously solve MCQs. And always remember that practice is the only master key to crack a NEET exam. I've prepared my lessons here in such a way that these are useful to all the NEET aspirants, and as well as students from class 12 NCERT state children. And also I'll be uploading lessons from NCERT class 11. And with that I'll be winding off for today, and I'll come back again soon with another amazing session. And thanks for watching.